Right, good day, my fellow students. I am Dr. Tay over here, and I will be covering the second part of the lecture series, continuing from where Dr. Teo left off. So, most of my lecture will focus on the applications of the theory that you have learned from Dr. Teo. So, the first one, we will start from voltage regulation, which we will go through later. In the second chapter, we will go through the electrical power distributions, the protections of the electrical power distribution system. And the third part will be on the reliability analysis of the distribution system. So in this voltage regulation chapter, all theories you have been learned before, which will focus on the voltage drop concept. For example, on the uniform voltage drop concept, you have the equations L multiply K over S. And if it's a uniform, then L you have to divide by 2, right? The same here. So it's easier if I use an example to demonstrate the concept rather than going through discussions of the concept through words, right? So this is a typical systems of a distribution network where you have the voltage from a larger voltage level, the transmission level. You step down through the transformer to the distribution level, and this is the distribution bus that is separated into several smaller transformer, which will distribute the load further to more loads along the feeder, which you can tap it out from. So this is the base value voltage for this level. This is the voltage level, base voltage value for this level, and this is the base MVA for the transformer LTC. So let's go through the information that we can, the descriptions of the data of the network, so that we can analyze what kind of data we can extract from it and what kind of analysis we can perform. Right. So this example investigates the use of a step-type voltage regulator to improve the voltage profile of distribution system. Figure 1 illustrates the elements of a distribution substation that is supplied from the sub-transmission loops and feeds several radial primary feeders. So I'm going a little bit fast here, so on things that is not important. So on the important one, I will slow down and explain, so because you can go through the slide on your own, right? So the substation LTC transformer can be used to regulate the primary distribution voltage VP bus, holding VP constant as both the sub-transmission voltage and voltage drop in the substation's transformer vary with load. So what this says is that the LTC transformer, as simple as that, right? The LTC transformer can be used to regulate the voltage of the primary bus, VP. So if we know the voltage drop in the LTC, which is given to us by Isaac T, then we can use the change of the transformer tab to control the VP that we want. So if the typical primary feeder main is voltage drop limited, it can be extended further and or loaded more heavily if a feeder voltage regulator bank is used wisely, which is the focus of this chapter. So if we use a regulator, then we can control the desired voltage drop. If we can control the desired voltage drop, we can control how much we want to load our feeder. So in figure 1, the feeder voltage regulator is indicated with the symbol shaped as a 0 with an arrow going through it. It is located at the point S equal to S1. S1 can be any point of the system, and it varies the boost and bump automatically to hold a set voltage at the RP, which is the regulating point, and that is S equal to SRP. So S equals to S1, S equal to SRP. So SRP and S1 can be on any point of the feeder, but SRP has to be after S1. That makes sense. And if SRP is on S1, it is possible as well. If SRP is on S1, it means that the regulator is not regulating anything at all. And we have one more thing, VRR, which is the voltage regulating relay. And it is used to adjust. Okay, it is used to adjust. It is adjustable between 1110 and 125 volt. And the VRR measures the voltage at the regulating point. Okay, by the means of a load line drop compensator LDC. So VRR is the relay, LDC is the measuring tool that is located inside um, our voltage regulator. So VRR and LDC are both located inside voltage regulator. LDC, okay,